So the concept of couples relates with the concept of moment in two dimension for this time. Yeah, maybe there will be also couples in three dimension. What is a couple? So a couple occurs when there are two forces having the same magnitude but opposite in direction, and they have parallel line of action. So as shown in this example, we have here a force working at point A and a force working at point C. Okay, at point both forces are 100 Newton in magnitude, and while at A it is pointing upward and at point C it is pointing downward, and their line of actions parallel, and this form a couple. And let's see now the resulting moment occurs at several different points. For example, first, when we calculate here moment about point A, okay, then the force at A will not exert any moment about point A because it occurs at that point. Okay? So the only moment that occurs about point A comes from the force that is exerted on point C. So then moment about point A is this 100 Newton, since multiplied by 1 plus 3. The sign is positive, since intuitively also it would rotate the structure clockwise, about point A. 100 multiplied by 1 plus 3 or 4, so equals to 400 Newton meter. Then moment about point B. Let's calculate now moment about point B. Now both forces will start to have contribution to the moment about point B. First, moment due to force at C equals to 100 Newton clockwise multiplied by 3 meter. Then moment due to the force at point A, 100 Newton, also intuitively it will turn the structure clockwise. So 100 times the distance, 1 meter, this one. Then equals to 300 plus 100 equals to 400 Newton meter. Let's calculate now moment about point C. About point C, the force at C, the force exerted at point C will not have any contribution to this moment about point C because it occurs at that point, at the axis. So then it doesn't rotate the structure about that point. It will only give a translation. So the contribution for the moment only occurs from the force exerted on point A, which is 100 Newton multiplied by 1 plus 3, the distance, 4 meter, equals to 400 Newton meter. Then let's try to calculate moment about point D. Hence, all the two forces will have some moment contribution to point D. Moment due to the point A will become 100 multiplied, it will turn the structure clockwise, right? Because it is upward, so it will rotate the structure clockwise, multiplied by the distance, 1 plus 3 plus 2 equals to 6 meter, 100 times 6. Then moment due to the point, due to the force at point C is counterclockwise. So this is pointing downward, right? So intuitively, it will rotate the structure counterclockwise. So let's rotate here. Intuitively, the force here about point C will rotate the structure counterclockwise. So then we assign a negative sign here, minus 100 times 2 meter, 200. So 600 minus 200 equals to 400 Newton meter. Okay. So what can we learn from here is that all the moments that occurs about any point in the structure are the same. Whether we calculate moment about point A or whether we calculate moment about point B or moment about point C, moment about point D, the results are the same, which is 400 Newton meter. So this is the characteristic of couple. Moment produced by a couple is independent of the point the moment is taken. Okay, in any point that you take the moment, either at A, B, C, and D, and the previous example, the result will be the same, which is 400 Newton meter. The moment of a couple is a free factor. It is the moment can be placed anywhere on the rigid body. So you can place that moment on any place within the rigid body. Magnitude of the moment of a couple equals the force times the perpendicular distance between the line of action of the two forces. So here, the distance between the two line of forces is 1 plus 3, right? Which is 4 meter. So the moment caused by this couple will be 100 Newton times 4 equals to 400 Newton meter. Two couples are the same if the resulting moment are equal in magnitude and direction. Okay, and both couples are on the same of or parallel planes. Again, I repeat, two couples are the same if the resulting moment are equal in magnitude and direction, and both couples are on the same or parallel planes. Okay. So, for example, if we change this, coming back here, we compare it with different moment. Let's say we put another moment at this part, yeah. Yeah. Second moment here, then another force at this one. Yeah, well, this is 1 meter. It is also the same 100 Newton. This is also the same 100 Newton. So the moment due to the red arrows, the red forces here, due to this couple, yeah, this is another couple, will be the same with the moment caused by the initial moment here, because they have the same force and the magnitude, and they have also the same distance between them, which is 4 meter. Okay, so then why we will use to later calculate the equivalent moment or the equivalent due to the different couples. So for example, this is how many of these? 1, 2, 3, 4, 5. There are 5 moments, yeah, caused by different couples or one single moment here. All of them results in the same moment, magnitude, and also direction arrow, yeah, which is 360 Newton meter counterclockwise direction. Let's have a look at individual moment. Yeah. For example, here at the first moment is 19 Newton meter, right? And from intuition, we know that this will rotate. So this is like this direction, this also this direction. So it will rotate the structure counterclockwise. The value will be equals to 360 Newton meter. Yeah, negative. So it is counterclockwise. Or you can mention here clockwise. So minus 360 Newton meter clockwise or 360 Newton meter counterclockwise. The second moment, let's say second moment, I will give different color here. 120 Newton, this one downward, the other one, the 120 Newton force upward at point A. The distance between them is 3 Newton. So the moment caused by this couple, by these two exerted force, is 120 Newton multiplied by 3 meter. Okay, so you got it. Because it is counterclockwise, so minus 360 Newton meter clockwise, or 360 Newton meter counterclockwise. Okay, so if we put the reference is counterclockwise, then it is positive. But if we put the reference is clockwise, then since the direction is actually counterclockwise, then we assign negative sign here. Okay, the third moment. The third moment here. Now, this is not that easy. So based on Pythagoras theorem, we know that the distance between these two forces, these two parallel forces, is 5 meters, right? From square root of 9 square plus 4 square, so equals to square root of 9 plus 16 equal to square root of 25. This is 5 meters. So the moment caused by this couple equals to 17 Newton multiplied by 5 meters. So equals to negative 360 Newton meter also. Yeah, because this also will turn the structure counterclockwise. Finally, here we have immediately a moment, 360 Newton meter, right? So this also will rotate the structure about counterclockwise about point C. Or otherwise, we can express this into like this, into a couple, yeah, having two forces opposite in direction, yeah, and parallel lines of action with a value of 360 Newton meter. Okay, so this shows that all the 5 pictures express the same couple reaction, yeah, the same couple reaction. Okay. Any questions so far? Quite clear, yeah? Let's try now. Yes?
I don't really understand the third one. Why is it 5? I mean, why the distance is 5?
Yeah,
The
the
center
distance.
is B, right?
Sorry?
The center is B, right?
The center is?
B.
No.
Oh.
This is the line of action of the first force is this one, right? The center of the second force is this one, line of action. What matters is, remember the formula of moment is mf times d in 2 dimension, yeah? D here is the distance between the line of force.
Yep.
Line of force to that point. So it is not this and this. The line of force is this one. So the distance is this one. If you are meant, what you meant is this force. And this one is this one. Okay. You can calculate also based on this. You can calculate 172 Newton here, negative, multiplied by this distance. You need to calculate later using Pythagoras theorem also what is this distance. Then multiplied plus negative also, because this will also give a counterclockwise rotation about point B. This minus 72 Newton multiplied by this. Okay. Then the result will be still 360 Newton meter. Okay. So this is already in from the previous slide. Yeah? So this is already the conclusion. If you calculate one by one, the result will also still be equal, 360 Newton meter. Yeah, remember from the previous one.
Terima kasih.
This one. Here, remember this example. At any place we put the force, at whatever bound point in that structure, it will have the same result. Whether we calculate moment about point A, whether we calculate moment about point B, they will result in the same value of moment, 400 Newton meter. So here, it doesn't matter here whether you calculate moment about point B. It's basically the same as you calculate moment about point A or moment about point C. Right? If you calculate here moment about point C, then you don't calculate the contribution due to this force.
Yeah.
Rather, only from this force. 72 Newton multiplied by 5.
Oh, okay.
Or you can calculate also moment about point A. So you don't calculate the contribution to the moment due to this force. Rather, you only calculate the contribution due to this force, which is also 72 Newton multiplied by 5. Alternatively, then you can calculate also about point B, but then you need to calculate the distance later, which is more complex. Then also the result should be minus 360 Newton meter. Should be the same. Okay, then so we can also add and subtract moment. For example, here the moment due to this couple 16 is 60 Newton meter. Then we have another moment about point C is 20 Newton meter. So here, this one will rotate the structure counterclockwise. This also will rotate the structure counterclockwise. So the total moment due to this one moment and one couple equals to the addition of both. Yeah? So 80 Newton meter counterclockwise. So similar here, we can express these three equally. So first, in the first expression, we express it as one single moment about point C counterclockwise, 20 Newton meter, and one couple, 60 Newton meter clockwise. So the total moment will be 60 minus 20 equals to 40 Newton meter clockwise. Okay, clockwise. So if it is expressed as counterclockwise moment, then it is equals to negative 40 Newton meter. If it is expressed as clockwise moment, then it equals to 40 Newton meter. Okay. Now this is in 3 dimensions. This is more complex. So the same with 2 dimension, basically a couple is when they have parallel lines of action, the magnitudes are the same of the two forces and opposite. Yeah, the direction of the force is opposite to each other. So here, if we calculate moment about point O from these two forces, remember, then first we calculate the moment due to the first force here, force A. Then we calculate RA cross the force here, which because it is directed towards minus C. So let's say we assign here negative F plus the moment due to this force B, which is then RB cross the force. So these are all in vector. Yeah. So be careful in 3 dimension. You have to express everything in vector. This is just because it is in PowerPoint. Then it is written as italics notation. So then moment about point moment due to the about point B here is RB minus RA cross F. Okay, this is the moment due to these couples. Yeah, RB from here, RB minus RA cross F, cross product. But RB minus RA equals to this R, right? RAB. Yeah, this R is RAB. Let's say this one, RAB, which is equals to the factor from pointing from the endpoint of A to the beginning point of B equal to RB negative RA. Yeah. So then moment about point O equals to this RB minus RA cross F. Observe that the moment of the couple is independent of point O. So see here that we don't really care about the position of the beginning point A here relative to the origin point, as well as the beginning point of B to the origin point. What we care now only the factor between the beginning point of A towards point B. So whenever you put these two couples, you shift the two couples anywhere in the 3-dimensional space, they would still have the same result, right? So similar like the previous examples in 2 dimension. Clear, yeah? So this is in 3 dimension. So what matters now is only this factor between the beginning point of A and the beginning point of the other force B. Okay. So we can have equivalent couples in 3 dimension. moment of couple shown are equivalent if RP here, the beginning, the vector between the beginning points of the two forces are equal. So moment of couple shown are equivalent if RP cross P equals to RQ cross Q. Okay? And they have to be, the two couples have to be both on the same or parallel plane. So for example here, we shift, but not only shift, we rotate the direction of the couples. Still, they will still create similar or the same moment, yeah, because they are the same magnitude, parallel to each other. The vector between the beginning points of the two forces are the same. RP and RQ are the same. The difference is only the direction. They are the different point at different planes, but they have to be parallel. We can add or subtract also couples. For example, we have here M1, yeah, moment due to a couple, which is in vector, in three-dimensional vector notation, we express it as myxi plus myj plus m1zk. And moment 2 equals to m2x, m2y, j plus m2zk, so m2xi. So when we add these two moments, it becomes m1 plus m2, yeah, equals to myx plus m2xi plus m1y plus m2yj plus m1z plus m2z. Okay. We can also subtract the two couple. Yeah, m equals, for example, m equals m1 minus m2. This becomes, we just subtract the vector components. m1x minus m2xi plus m1y minus m2yj plus m1z z minus m2zk. Okay. For example, here. So this is already solved. Before, let's have a break. Yeah, so it's already 9:58. Let's have a break first. So I will. Okay, we continue with our example for three couple in 3 dimension. So here we are asked to replace the two couples shown here in this diagram with one equivalent couples. So be careful that all dimension here is in millimeter. Usually when it is in exam or test, try to convert it first into meter. Yeah? So the unit will be standard Newton meter. So for example, here we have the first couple, 18 Newton. Yeah, it's parallel in the XZ plane. One is towards positive Z direction, the other one 18 Newton towards negative Z direction. The other one is in this plane, BCD, with complex plane. 34 Newton here from point D towards this point. The other one is 34 Newton from C, which is on that same plane with D, to the x-axis. So we are asked to replace these two couples into one single equivalent couple. So first for the 18 Newton couple, we calculate the moment equals this one, yeah, R cross F. The R means from the distance between this point to this point. Okay, so which is shown basically here is 0.17. This one is 0.3. So we can calculate using using Pythagoras theorem. So the two choices, if the force is plus 18 Newton K, so it means we choose this direction, 18 Newton K. It means then the R will be minus 0.3 mi, 0.3 mi meter I. So this to this point. So 0.3 from here minus 0.3 meter I. So pointing negatively, the RB cross RA. So let's say here, because this one RA here, the position of A here equals to 0I and plus 0.17 meter K, right? RB, if in this one here, let's say this is equals to 3 meter I plus 0K. So if we choose this point from A, so the factor here, the X component will be is RA minus RE. So 0 minus 3 meter will be equals to minus 3 meter I. Okay, minus 3 meter I. So this one here, if we choose F equal plus 18 Newton K, then R will be equals to minus 0.3 meter I. And so if we see before, why the K component of R is not included, because basically when K cross product with K, the result is 0, right? When remember in cross product, when they are in the same means sign, the sign is 0, the angle is 0 to each other. That's why we in cross product, what matters is when the multiplication is between values from different axes. So if we choose F equals to minus 18 Newton K, on the other hand, so means this part, yeah, the minus 18 Newton K, so the R will be this R, which is 3 meter I minus this one, 0. So becomes plus 0.3 meter I. So both will produce the same. So the M due to this first couple, 18 Newton, will be minus 0.3 meter I cross plus 18 Newton K, or equals to plus 0.3 meter I cross minus 18 Newton K, equals to 5.4 Newton meter J. Then for the 34 Newton couple, M2 equals to the R between the two forces, yeah, R cross F. F is 34 Newton. So first is we determine the component of the force F. We look for the lambda first, the unit factor at the axis of the force. So F equals F dx divided by di plus dy divided by d multiplied by j plus dz divided by d multiplied by k. The value of F is 34 Newton. So here, if we take F at C, so here at the C, so that becomes RC minus RD, okay? So the X component is 0.15 here. So the X component is 0.15 I plus the J component is minus 0.08. The J component is in the y-axis. The y-axis is 0.018, half of this 0.16. This one. So what it means, what we are calculating here is actually this factor. This factor here, yes. Factor R. Okay. Then the J component is minus 0.17 divided by 0.2404K. Minus 0.17 is this part, the K component. So then we obtain 21.2 Newton I. This is expressing the force first, yeah? This expressing this force F. X, yeah, the Y is negative. Yeah. minus 11.3 Newton J minus 24 Newton K. Okay, because this force factor C is going towards minus Z direction, going towards minus Y direction. Okay. So this is what it implies. Then the position factor, first screw drawing, from D to C. So see here, from D to C here will be R equals to 0.17 meter K. Okay, so from here to here, so RC minus RD equals to this value, yeah, which is 0.17 meter. This one, yeah, equals to this, because this lies, it doesn't have any X component, it doesn't have also Y component, it only has Z component, so equals to 0.17 meter K. So having this, then the moment due to that couple 34 Newton equals to 0.17 meter K cross the previous value of the force that we have calculated in the previous slide, 21 Newton I minus 11 Newton J minus 24 Newton K. So what matters now is only this value. This doesn't have any results here, so we obtain so the value will be in J and I. Then we obtain 1.921 Newton meter I plus 3.604 Newton meter J. So then the equivalent couple, yeah, one equivalent couple will be the addition between couple 1 plus couple 2. 5.4 Newton meter J plus 1.921 Newton meter I plus 3.604 Newton meter J. So here added to this one, so equals to 1.921 Newton meter I plus 9.004 Newton meter J. So this is the equivalent couple or equivalent moment due to the two couples. Okay, now sometimes we may also have force couple system. In this case, in a structure, a couple occurs at the same time with a force. So we need to move the force to a different location from O to A, for example. So here we will change. We have initially a force occurs here at point O. Okay, we can change this into a force and a couple. Okay? Because when we this force will have occurs at the structure, basically will also rotate the structure, right? So then it will create basically a translational motion as well as a rotational motion. So it means we can replace this with another force occurring at the axis of that rotation plus a moment at that point, yeah, about that point. So for example here, that we have a force at point O with an angle theta towards the horizontal line. We want to replace it with a moment at about point A and as well as another force at point A. So how to do that? We add this with two forces opposite to each other happen at the same point, here at point A. So basically this will cancel each other, right? So it's like adding a variable with a number, two numbers, both having the same magnitude, the same value, but opposite sign. Basically then it will result the same. From the translational point of view, this will result the same resultant, the same force resultant, which is this force. But however, from here, from this force that is going leftward and this with the original force, basically we have a couple, right? Because they are the same magnitude, they are opposite to each other, and they have parallel lines of action. So we can replace these two forces, this couple, into a single moment whose value equals to force times d, right? So this then the result, the final result becomes a single moment about point A plus a new force uh, originate from that point A. So this will create translational motion through this structure as well as rotational motion about point A. Basically equals to the original system, which is the force at point O. So find the moment of the force about point A. We detach the force and place it at point A. Exercise 1, 2. Yeah, there are 2 exercises. Yeah, let's do this exercise 2 instead. Replace the system of forces and a couple acting on the rigid body with an equivalent force couple system at D. So here we have how many forces here? Force at point B, 212 Newton, whose line of action is directed towards point E here. 100 Newton here at point A and 100 Newton at point E, opposite to each other, and their lines of action are parallel. So we know that then this is a couple. Then we have another force at C. So we are asked to replace all this system of forces and this couple, these forces and these forces and this couple into an equivalent force couple system at D. It means we are asked to replace this with a single force at here or yeah, and a single moment at D. Or it could also be clockwise. Yeah, depends. Okay, so let's do this as homework. So